requirement for switch duty rated breakers for both 120 and 277 volt circuits was introduced in the 1996 National Electrical Code, or NEC. Prior to that, the 1978 NEC in section 240.83 required switch duty rated breakers only for 120 volt circuits and made reference to the heavy duty contacts found in 277 volt breakers. If a building's electrical system was installed prior to the 1996 NEC, it's possible that the installation was compliant with the code at that time, and the current requirement for switch duty breakers might not apply to those existing panels. In the scenario of a plant wanting to replace every breaker in every panel with switch duty rated breakers for lighting circuits, several arguments could be made against the necessity of such a complete replacement. Firstly, the original installation was likely code compliant at the time of installation. Secondly, the breakers may be used infrequently, if at all, to de-energize lighting circuits. Thirdly, replacing all breakers in every panel could be a significant expense and might involve extensive panel upgrades, particularly in older systems. However, there are also considerations that argue for the replacement of breakers with switch duty ratings. Firstly, from a safety perspective, switch duty rated breakers can enhance safety by reducing the risk of short circuit and ground fault fires, especially in circuits used for switching lighting. Secondly, future code enforcement could become a factor if the plant undergoes major renovations or expansions, potentially requiring the panels to be brought up to current code standards, which could necessitate the installation of switch duty breakers. Thirdly, insurance requirements might also play a role, as some insurance companies may stipulate the use of switch duty breakers as a condition for coverage. A possible compromise could be to selectively replace only those breakers that are likely to be used frequently as switches for lighting circuits. This approach would minimize the overall cost and disruption while still improving safety in areas where circuits are regularly de-energized. The ultimate decision on whether to replace the breakers should be based on a thorough risk assessment, taking into account the potential safety benefits, the associated costs, and the likelihood of future code enforcement requirements. A qualified electrician should be consulted to conduct a comprehensive assessment of the specific situation and provide tailored recommendations. To elaborate further on the technical aspects, let's delve into the specific requirements outlined in the National Electrical Code regarding switch duty rated breakers. Section 240.83 of the NEC addresses the marking of circuit breakers used as switches in 120 volt and 277 volt fluorescent lighting circuits. Circuit breakers used to switch these circuits must be marked switch duty or SWD. This marking indicates that the breaker has been specifically designed and tested to withstand the repetitive switching operations that are common in lighting circuits. The heavy-duty contacts in switch-duty rated breakers are designed to minimize contact wear and prevent premature failure due to the arcing that occurs during switching. In contrast, standard circuit breakers that are not switch-duty rated may not be able to withstand the stresses of frequent switching, potentially leading to reduced lifespan, increased risk of failure, and the possibility of electrical hazards. When considering the replacement of breakers in an existing electrical system, several factors should be evaluated. Firstly, the age and condition of the existing breaker should be assessed. If the breakers are old, corroded, or show signs of wear, replacement may be warranted regardless of whether they are switch duty rated. Secondly, the frequency with which the breakers are used to switch lighting circuits should be taken into account. If the breakers are rarely used for switching, the need for switch duty rated replacements may be less critical. Thirdly, the overall condition of the electrical panel should be evaluated. If the panel is old, damaged, or does not meet current safety standards, it may be more cost-effective to replace the entire panel rather than just the breakers. When selecting replacement breakers, it's essential to ensure that they are properly rated for the circuit in which they will be installed. This includes verifying the voltage rating, the amperage rating, and the interrupting rating. The voltage rating of the breaker must be equal to or greater than the voltage of the circuit. The amperage rating of the breaker must be matched to the ampacity of the circuit conductors. The interrupting rating of the breaker must be sufficient to safely interrupt the maximum available fault current at the installation location. In addition to the breaker ratings, it's also important to consider the physical size and configuration of the breaker. Replacement breakers must be compatible with the panel board in which they will be installed. Different panel board manufacturers and models may use different breaker types, so it's crucial to select the correct breaker for the specific panel board. When replacing breakers, it's essential to follow proper electrical safety procedures. This includes energizing the circuit before working on it, using appropriate personal protective equipment, and verifying that the circuit is properly grounded. It's also important to carefully inspect the wiring connections to ensure that they are clean, tight, and properly insulated. Furthermore, any applicable local or national electrical codes should be followed, including proper labeling and documentation of the replaced breakers. For example, NEC Section 110.22 requires that all electrical equipment be marked with its voltage, amperage, wattage, or other ratings as necessary. This helps ensure that the equipment is used safely and correctly. It's also worth noting that some jurisdictions may have specific requirements for the installation of switch-duty rated breakers in certain types of buildings or occupancies. These requirements may be more stringent than the NEC minimum standards. To summarize, the decision to replace existing breakers with switch-duty rated breakers involves a comprehensive assessment of various factors, including code compliance, safety considerations, cost implications, and potential future needs. While the 1996 NEC introduced the requirement for switch-duty rated breakers in both 120-volt and 277-volt circuits, installations prior to the date may have been compliant with the codes in effect at the time. However, it's crucial to weigh the potential safety benefits of upgrading to switch-duty rated breakers against the cost and disruption of a complete breaker replacement. Consulting with a qualified electrician is essential to ensure that the decision is based on a thorough understanding of the specific circumstances and applicable codes. Remember that the National Electrical Code is updated regularly, and it's important to stay informed of the latest requirements. The NEC is published by the National Fire Protection Association, or NFPA, and is available for purchase or subscription on their website. In addition to the NEC, there may be other applicable standards and regulations that should be considered, such as those issued by Underwriters Laboratories, or all, the Institute of Electrical and Electronics Engineers, or IEE, and other industry organizations. Staying up to date on these standards and regulations is essential for ensuring the safety and compliance of electrical installations. Let's further clarify the nuances between standard breakers and switch-duty rated breakers. Standard circuit breakers are designed primarily for overcurrent protection, meaning they are intended to trip and interrupt the circuit when an overload or short circuit occurs. They are not specifically designed to withstand the mechanical stresses and electrical arcing that occur during frequent switching operations. Switch-duty rated breakers, on the other hand, are specifically designed and tested for frequent switching applications. They have more robust contacts and internal mechanisms that can withstand the repetitive opening and closing of the circuit without premature failure. The contacts in switch-duty rated breakers are typically made of materials that are more resistant to arcing and wear, such as silver tungsten alloys. The internal mechanisms are also designed to minimize contact bounce and vibration, which can further reduce wear and improve reliability. In addition to their enhanced durability, switch-duty rated breakers may also have other features that make them better suited for switching applications. For example, some switch-duty rated breakers have a faster trip time than standard breakers, which can help to reduce the duration of electrical arcs during switching. Others may have a higher interrupting rating, which means they can safely interrupt higher levels of fault current. When evaluating the need for switch-duty rated breakers in a particular application, it's important to consider the frequency of switching, the type of load being switched, and the environmental conditions. In applications where the breakers are used frequently to switch lighting circuits, motor loads, or other inductive loads, switch-duty rated breakers are generally recommended. In harsh environments, such as those with high levels of humidity, dust, or vibration, switch-duty rated breakers may also be a good choice, as they are typically more resistant to these factors. It's also worth noting that some manufacturers offer circuit breakers that are both overcurrent protective devices and switches. These combination devices, sometimes referred to as circuit breaker switches, can provide both overcurrent protection and switching functionality in a single unit. They are typically more expensive than standard circuit breakers, but they can save space and reduce wiring complexity in some applications. Before making any decisions about breaker replacements, it's advisable to conduct a thorough load analysis of the electrical system. This involves measuring the actual current draw of the lighting circuits and other loads to ensure that the existing breakers are properly sized and that the system is not overloaded. The load analysis should also take into account any future expansion plans or changes in load requirement. In addition to the load analysis, it's also important to inspect the wiring and connections of the lighting circuits. Loose or corroded connections can cause voltage drops, overheating, and other problems that can affect the performance and lifespan of the breakers. Any damaged or deteriorated wiring should be repaired or replaced. If the existing electrical system is very old or in poor condition, it may be more cost-effective to replace the entire system rather than just the breakers. This can provide a more reliable and safer electrical system that meets current code requirements. When replacing an entire electrical system, it's important to hire a qualified electrical contractor who has experience with similar projects. The contractor should be able to design and install a system that meets the specific needs of the building and complies with all applicable codes and regulations. In summary, the decision to replace existing breakers with switch-duty rated breakers is a complex one that requires careful consideration of various factors. These factors include code compliance, safety, cost, and the specific requirements of the application. Consulting with a qualified electrician is essential to ensure that the decision is based on a thorough understanding of all the relevant factors and that the work is performed safely and in compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it's always best to leave it to the professionals. Improperly installed electrical equipment can pose a serious risk of fire, shock, and other hazards. By hiring a qualified electrician, you can ensure that the work is done safely and correctly and that your electrical system is reliable and compliant with all applicable standards. Let's expand on the potential cost implications of replacing all the breakers in a plant's electrical system. The cost of replacing breakers can vary significantly depending on several factors, including the number of breakers, the type of breakers, the labor costs, and any necessary panel upgrades. The cost of switch-duty rated breakers is typically higher than that of standard breakers. This is due to the more robust construction and enhanced features of switch-duty rated breakers. The labor costs for replacing breakers can also vary depending on the complexity of the work and the hourly rate of the electrician. Replacing breakers in a panel that is easily accessible and has plenty of working space will typically be less expensive than replacing breakers in a panel that is difficult to access or requires extensive wiring modifications. In some cases, replacing breakers may also require upgrades to the electrical panel. For example, if the existing panel is old or does not have enough capacity to accommodate the new breakers, it may need to be replaced. Panel upgrades can be a significant expense, as they often involve rewiring and other modifications to the electrical system. Before undertaking a breaker replacement project, it's important to obtain multiple quotes from qualified electrical contractors. This will help to ensure that you are getting a fair price for the work. When comparing quotes, be sure to consider all of the costs involved, including the cost of the breakers, the labor costs, and any necessary panel upgrades. It's also important to ask the contractors about their experience with similar projects and their knowledge of the NEC and other applicable codes. In addition to the direct costs of breaker replacement, there may also be indirect costs to consider. For example, the plant may need to shut down operations during the breaker replacement work, which can result in lost productivity. It's also possible that the breaker replacement work could uncover other electrical problems that need to be addressed, which could further increase the cost of the project. Before proceeding with a breaker replacement project, it's important to carefully weigh the costs and benefits. If the existing breakers are functioning properly and are not posing a safety hazard, it may not be necessary to replace them. However, If the breakers are old, damaged, or do not meet current code requirements, replacement may be warranted. A qualified electrician can help you to assess the condition of your existing breakers and determine whether replacement is necessary. It's also important to consider the potential long-term benefits of replacing breakers. For example, new breakers may be more reliable and less likely to fail, which can reduce the risk of electrical outages and downtime. New breakers may also be more energy efficient, which can save money on electricity bills. In addition, replacing breakers can improve the safety of the electrical system, which can reduce the risk of fire, shock, and other hazards. Ultimately, the decision of whether or not to replace breakers should be based on a careful consideration of all the relevant factors. These factors include the age and condition of the existing breakers, the frequency of switching, the type of load being switched, the environmental conditions, the cost of replacement, and the potential long-term benefits. Consulting with a qualified electrician is essential to ensure that the decision is based on a thorough understanding of all the relevant factors and that the work is performed safely and in compliance with all applicable codes and regulations.